All right, today's lesson is lesson 20, types and areas of triangles. What's our objective, class? Get ready?
Types and areas of triangles.
Good. I need a smart and snappy response. One more time. Types and areas of triangles. What?
Types and areas of triangles.
Good. Types and areas of triangles. Today you're going to identify types of triangles based on their angles and based on their side lengths. They're two completely different categories, so we're going to make sure we know the difference between the categories. We're also going to talk about area of a triangle. So we know angles that are acute, right, and obtuse. We've talked about that yesterday. Today we're going to talk about a triangle whose largest angle is acute, or right, or obtuse. If the largest angle in the triangle is one of those, that's the name of the triangle. So you classify a triangle by its largest angle. Which angle is it, class? Get ready.
Largest angle.
The largest. Give me a smart, snappy response. Which angle is it, class? Get ready.
Largest angle.
Largest angle. So know that all the degrees in the triangle, the angles, all add up to 180 degrees. How many degrees, class? Get ready.
180 degrees.
180 degrees. So is it possible to have two angles in a triangle measuring more than 90 degrees? So let's draw a 91 degree angle. It's just a little bit bigger than 90.
It is.
Can I have another angle in a triangle that's a little bit bigger than 90? So I'd have to draw it right here, right? I can't have a triangle now.
No.
It would be impossible. So the only way is for the other two to be acute. They have to be less than 90. And this one, there's only one obtuse angle. But if one of them's bigger than 90, it's called obtuse. What is it called, class? Get ready?
Obtuse.
Obtuse. That brings us to our three names for angles. It's acute, right, and obtuse. The first one, our largest angle, probably is, it's either this one or this one. It's hard to tell. But the largest one is still less than 90, so the whole triangle is an acute triangle. What is it? Get ready?
Acute.
Acute. If the largest angle is a 90 degree, we call it a right triangle. What?
Right triangle.
Right triangle. And if the largest angle is an obtuse, we call it obtuse. I tricked some teachers in the school. We were doing a lesson before school started, and I drew a triangle like this. And I said, what type of triangle is that? Is it acute, obtuse, or right? And I had a couple teachers get it wrong. What is it, Alex?
Right.
No. Evelyn?
Right.
It's obtuse because the largest angle is this one. Even though this one's on the bottom, those are acute, but the largest angle is obtuse, and you classify based on its largest. So this is an obtuse triangle. Okay, good. All right, so those are your three choices. That's for classification by angle. Now, on length of sides, there's a whole different system. Equilateral, isosceles, scalene. Raise your hand if you've heard those words before. Okay, pretty much every one of you. Equilateral, the root word equal or equa. All sides are equal. This is an equilateral. What?
Equilateral.
Equilateral. I need everyone to choral response, okay? What is it called? Class, get ready?
Equilateral.
That's better. This side, you're a little bit better than this side, so let's bring it more. I need more of you. This side, this one is called isosceles. What?
Isosceles.
Isosceles. That's better. There's two sides in an isosceles triangle. Two sides are congruent. In a scalene, none of them are congruent. So I have a short one, a medium one, and a long one in a scalene. This is called scalene. What?
Scalene.
Scalene. So let's look at it just so happens in an equilateral triangle, because they're the same, if you look across the triangle to that angle and across to this angle, they all have to have matching angles. Otherwise, you couldn't have matching sides. It's the only way to do it. If I move this angle to be a little bit bigger, like this, suddenly I'd have a longer length side and I wouldn't have an equilateral triangle. So they have to match. They have to all be the same. We use little notations like this to show that they're the same. In an isosceles, the base angles, or the ones opposite, are congruent. So it has two angles here. So if I drew my isosceles like this, okay, these two match. The base angles then are here and here. In a scalene, none of the angles can match. They couldn't because the side lengths are different. Spencer?
Will the polygonal triangles also be acute?
Yes, very good. So there's two names for this. Based on angle, it's acute. Based on side length, it's equilateral. Okay, great observations. You're going to have a practice set question like that. All right, let's continue. So we talked about, hey, that triangle that had equilateral length, if all three angles are the same measure, and we know that all of the angles add up to 180 degrees, could we figure out what one angle would be? So they all add up to 180, and they're all the same, so that means I could divide by 3. 180 divided by 3, think. Get ready?
60.
60 degrees. So in an equilateral triangle, they have to be, and they will always be 60 degrees. They just always are. All right, so let's see how well you were listening. You're going to call on students. Maybe we'll answer some of the class. Let's classify a triangle ABC by angle and by side. What do we know about it? We know this is a 90 degree. We know this is a 60 degree. By visually I can see this is short, medium, long. So if I were talking angles, your choices are acute, obtuse, right. What is this one thing? Actually, I'm going to call an individual student. Bryce. Your choices are acute, obtuse, and right. It's a right triangle. What is it, class? Get ready?
Right triangle.
All right. Its largest angle is right there, and it's a 90 degrees, so it's right. Okay, by sides, your choices are equilateral, isosceles, scalene. What would we call it? Give it, John.
We call that a right triangle. No, isosceles, scaling, that would be a scalene.
Scalene. What is it, class? Get ready?
Scalene.
Scalene, because I've got a short one, a medium one, and a long one. So it's scalene. So that's why I have two names to describe this triangle. One by angle, one by side. So it's a right scalene. Let's do another one. Oh, I thought I had another one. I don't have another one. Okay. We're going to talk about area now. So look at this triangle. It's enclosed in this rectangular grid. The question is, what fraction of the area of the rectangle is the area of the triangle ABC? Meaning, if I were to shade this in, what fraction of the whole rectangle does this triangle take up? Is it a third of it? Is it a half of it? So put your hands down. We're gonna explore that. It's hard to tell because they're kind of cutting in different. I couldn't really add up. That's a whole square. That's a part of the square. So I'm gonna do this. I'm gonna break it up right here. And here, and here, and here. And I'm going to look at just this. If I cut it from corner to corner, would you say that this is half of this? Could I do the same thing on the other side? Would you say that this is half of this?
Yes.
So could I say, combining the two, this is half of the whole thing?
Yeah.
So the triangle, I'm going to say the area of the triangle space is 1/2 of the area of the whole rectangle.
A triangle equals 1/2.
It's 1/2 of the rectangle that's around it. Well, let's look at what that rectangle is. The rectangle is 1, 2, 3, 4, 5, 6, 7 units across. 1, 2, 3, 4 units. So the area would be 7 times 4, or 28, or 14 square units. That's the area of the triangle. Does this look a little bit to you like a formula you've seen before?
Yes.
Right there. The area of a triangle is 1/2 the base times the height. Wasn't that base and height the dimensions of my rectangle? Okay, look back here. Wasn't this the base?
Yeah.
Isn't this the height? Base, height, right there. So the area of a triangle is 1/2 base times height. What's the area of a triangle, class? Get ready?
Base.
1/2 base times height. Now in other teachers or other classes you might say base times height divided by 2. I don't. The students always forget to divide it by 2. They always forget that. That's the mistake they always make. They forget to divide by 2. So I put it in front. It's 1/2 and then you don't forget it. Take 1/2 of the base times height. What is it, class? Get ready? 1/2 base times height. Write that in your notes if you haven't already. Look up when you're done. Jacob.
How I know? I just thought of this when I was doing the test at the beginning of the year, and they were like putting us in groups and everything. And I thought it was like, it was, the base and height of the square of.
The triangle?
Yeah, the triangle, divided by 2.
It is. It is.
But you just
But
said it
every
different
triangle fits inside of a square.
ways. All triangles do.
This triangle could fit inside of a square. So if I found that square, it'd be 6 times 8
Divided by 2.
divided by 2. Our base in this case is 8. Our height is 6. Look for the perpendicular height. It's got to be perpendicular. So if I'm a person standing up here and I drop a rock, it's going to drop straight down. This is my perpendicular height. Area would be 1/2 base times height. I'm going to put base times height, which is 1/2, 8 times 6, which is 1/2 of 48, which is 24 inches squared. And the next one you're going to help with. What if it's an obtuse triangle and I don't have a perpendicular height inside the triangle? Can I use a perpendicular height outside the triangle? I can. So if I'm a person standing up here and that's a person, and they drop a rock. The rock's going to drop right down here. This is my perpendicular height. Base would be what? Think. Get ready?
6.
Oh, I need my base. My base. Get ready? 4. Okay. So if it helps you, that's the ground. Here's your person dropping a rock down to the ground. Your height is, get ready? 6. And so my area is 1/2 base times height, or 1/2 4 times 6. 1/2, 24, which is 12 centimeters squared. I had a student say, I don't even know what all this writing is, Mrs. Boone. This is a record of my work. This is showing work. This is saying, I know it's 12, and I could have done it in my head, but now everyone can see, oh, okay, she took half of the base times height. That's what she used for the base. That's what she used for the height. So if you make a mistake, you can go back, oh, I used 10 instead of 4 times 6, you can see a record of your work. So it's good to write down your work. All right, for you to try, you might need to change your perspective on this problem. It says I need a base and a height, and I have to have a perpendicular height. I know some perpendicular information in there. That's supposed to be a box, by the way. Write down your base, write down your height, and find area. As soon as you've got it, put your pencil up. Okay, some of us are stumped. We've got to change our perspective. Some of you are maybe tilts in your head. Can this be the base right here? It's going to have to be, because I need a base that has a perpendicular height. The only perpendicular height I know is this one, because it's a right angle. So that's my person standing on top, and he's dropping a rock this way. Picture if I just rotated it. Here's my 8. See that? I just went, boom. So that means the top of the triangle is here. Here's my guy up on top. Here's my vertical height, or my perpendicular height, 7 meters there. I really just need the 8 and 7. I don't need the 9 at all. So my base is 8, height is 7. Let's finish it out. What do I get, Spencer?
You get 28.
I get 28 what?
Meters squared.
Meters squared. Because I did 1/2 these two numbers, 8 times 7, or 1/2 of 56, which is 28 meters squared. Any questions on that? Okay, last question is graphing. You think, what's in course 3 that's kind of newer and maybe a higher level than in course 2? We're going to take a triangle, we're going to solve it graphically. I'm going to try to go fast. All right, 2, 1, let's plot this triangle. 1, 5 up here, 5, 5 up here. Let's draw the pieces to it. The question is, what's the area? We could use that box method. Remember how we drew the box around it? Like this. So if I found the area of the square, or the rectangle, and just cut it in half, I could do that. So what are the dimensions of my outside? 1, 2, 3, 4 units. 1, 2, 3, 4 units. The square, area of the square equals 4 times 4, or 16 units squared. So wouldn't my triangle be half of that? I should do that. Okay, I like it when you're nodding. It says, yes, I agree. So half of that, so it should be 8 units squared. What if I tried it the other way that we just learned? Base, and where's my height? Right there. Here's your perpendicular height, right to the peak. Here's your person. And they drop a rock, and it goes like here. There's the perpendicular height. We're in the upside down world today. Base is 4, and the height is 4. Same dimensions. 8 units squared. Give me a thumbs up if it makes sense. I got it. Give me a thumbs up if I knew everything you just taught already. Okay, a lot of you did. It was a little bit of a review. All right, here we go. We're on page 129, and you've got 4 problems already on the board.